Okay, welcome to day 3. Today we're going to be talking about inverse functions and relations. The goal for today is to be able to find the inverse of a function. Alright, to start, when we talk about functions and relations, two relations are inverse relations if and only if one relation contains the element AB and the other relation contains the element BA. So you're going to see right away from the start that in order to find an inverse relation, all we're going to do is switch the x and y value. Alright, so our first example. When asked to find the inverse of a relation, if you were given the points 1, 8, 0, negative 3, 5, 11, and negative 4, 9, the inverse relation would be 8, 1, the flip of 1, 8, negative 3, 0, 11, 5, and 9, negative 4. Okay, simple enough. Again, if we go back to the previous slide, again, the idea is we're switching the x and y values. Okay. Alright, so a second example. Take a second, see if you can come up with the inverse relation. Pause the video for a second, and then I'll start it up again. Okay, if you had time to come up with the inverse, you should have come up with the following. Again, all you're doing is switching the x and y values. You're not changing signs. That's a common mistake that most people make. They want to change like the negative 7 to a positive 7. We're not doing that. All we're doing is switching the x and y. Okay? Alright, so the next part is we're going to deal with the idea of finding the inverse function. A lot of times we'll see the inverse function with f to the negative 1 of x. The negative 1 being the inverse. So this basically means the inverse function of x. Then you're going to be asked to graph the function and its inverse. So big tip for tomorrow, try and bring graph paper to class so that you have some graph paper in which to graph the equations that you're going to need to graph. Alright, our first example is going to be f of x is equal to x plus 2. I'm starting off with a simple one just to kind of explain the steps as we go through. The very first thing you're going to want to do is you're going to want to change the f of x to a y. Think about it in terms of graphing. You have an x-axis and a y-axis. This will make things a little bit easier. Right? After I change the x or the y to an x, I am going to then switch the x and the y. Everything else is going to stay in the exact same spot. The 2's, any coefficients, any radicals, any exponents, all that stuff stays. The only thing that changes is the x and the y. So in this case, x is equal to y plus 2. Step 3, now what we want to do is we want to solve for y. We want to get the y by itself. So all we're going to do here is we're going to subtract 2 to the other side, and now the y is by itself, and we have y is equal to x minus 2. And then just a heads up, you know, kind of like what I have written at the top, you would write the inverse function of x is equal to x minus 2. Okay? Alright, so keep in mind those three rules and use them as we move forward. Alright, in terms of graphing, if we were to graph f of x is equal to x plus 2, remember that 2 is the y-intercept and there's a slope of 1, so we're going up 1 over 1 in each case. Okay, and then the inverse function is x minus 2, negative 2 is the y-intercept, and then the slope is up 1 over 1. And the key here is notice that if we look at each of the individual points on the line, that they are flipped. So 1, 3 becomes 3, 1. 0, 2 becomes 2, 0. Negative 1, 1 becomes 1, negative 1. I think you get the idea. So it's the same thing as the first exercise that we did. So here's a tip for you. If you have trouble graphing one of the functions, be sure to graph, you know, the inverse or the original function. And then in order to graph the other one, just all you have to do is switch the x's and y's. Alright, next example. Okay, if we take a look at f of x is equal to x minus 3 over 4. Step 1, first thing you want to do is change f of x to y. Step 2, switch the x and the y. The negative 3 stays, the 4 stays, everything else stays. Now we're going to solve for y. First thing I'm going to do is I'm going to multiply 4 to both sides. Then I'm going to add 3 to both sides, and now I've got y is equal to 4x plus 3, so that makes the inverse function 4x plus 3. Okay? So there's my inverse. Now, in terms of graphing, like I just said on the previous slide, if you're not sure how to graph x minus 3 over 4, well, you should be able to graph 4x plus 3, 3 being the y-intercept and a slope of 4. Okay, so as you can see, if you could graph 4x plus 3 and come up with the points -1, -1, 0, 3, and 1, 7, then to graph the f of x equal to x minus 3 over 4, switch all of these points. 1, 7 now becomes 7, 1, 0, 3 becomes 3, 0, and -1, -1 is going to stay in the exact same spot. So again, just a little tip for you. Alright, we've got one more example that we're going to look at. I want to make sure that you have this one written down in your notes. This one will for sure be checked for points tomorrow in class. Okay, but before we get there, a little trivia for you. What was the original flavor of Twinkies? Now that they've come back out, see if you can think of what the original flavor was. I'll give you the answer at the end of the video. Alright, so finding the inverse function of a given function and then graphing. So this time, I want to look at one in which we have an exponent. So if g of x is equal to x squared minus 9, step 1, change g of x to y. Step 2, switch x and y. Notice that the exponent stays where the minus 9 is. The only thing that's switching is the letters. Okay, nothing else moves. Okay, then my goal is to solve for y. That means I'm going to have to add 9 to both sides, and then I'm going to have to take the square root of both sides. And big reminder here is that whenever you take the square root of both sides, you should be thinking put plus or minus. Okay, so therefore we got plus or minus the square root of x squared plus 9. Okay, so our inverse function is plus or minus the square root of x squared plus 9. Now, we have not learned how to graph the square root of x squared yet. That's coming later on in the chapter. But we have learned how to graph y equal to x squared minus 9, parabolas. You should know that 9 is your y-intercept, and then since it's a parabola, remember that it's going up on both sides of that y-intercept. Okay, so if we take a look at the graph, okay, you got your f of x equal to x squared minus 9. Okay, you should be able to find a couple of points. I have the points 0, -9, 3, 0, and -3, 0, because 3 squared minus 9 is 0. -3 squared is 9 minus 0. Alright, so now in order to graph my plus or minus, well, all I need to do is switch these 3 points that I have. So -3, 0 becomes 0, -3, 3, 0 becomes 0, 3, and 0, -9 becomes -9, 0. And that can help you in terms of graphing. That concludes the video. Again, a couple tips for you. Please try and remember to bring some graph paper to class. And then number 2, come with questions so that they can get answered. And to come up with the answer to your trivia. The original flavor of Twinkies was actually banana. It changed after during World War II when there was a banana shortage. And then they had to change it to vanilla, and they just never changed it back since then. So, a little bit of trivia for you.